Is there any way I can jump up and never come back? How many of you believe that now I'm about to jump up and will never fall? I will never come back. How many of you believe that? Okay, let's see. Before me jumping up, let's try something else. Let's throw this eraser. How many of you believe that I will throw this eraser and it will come back? Almost everyone, right? Let's see. Oh, okay, it came back. So now I'm claiming that I will jumping up and I will never come back, I will escape. Well, let's see. I fall. Is there any way I jump up and I will go up and up and up, never come back? Well, there is a way. I have to move at least 11.2 kilometers per hour, kilometer per second. If I move 11.2 kilometers per second, which is 33 times faster than the speed of light, which is 33 times faster than the speed of sound. If I jump up, if I jump up 11.2 kilometers per second, which is 33 times faster than the speed of sound, I will never come back. I will go up, and I will eventually become the satellite of the Earth and orbiting around the Earth like that. Okay, but that's not the case. I cannot jump up without having a booster rocket underneath of my feet. Now, in general case, when we throw, it come back. When we jump up, we come back because gravity pushing us down. Now, how can we describe that behavior? The quadratic equation describes that behavior, and that's what we're gonna do. When we throw up, is come back is because there is a point in which the chalk changes the direction. At that point, what is the velocity? The velocity should be 0 because the chalk changes the direction. Chalk go up, and come back. In order for it to come back, chalk has to stop. When chalk stops, then the velocity should be what? The velocity should be 0. Today we're going to learn about linear function. Linear function is the simplest function of all functions, and their graph are simplest curve of all functions. However, we still need to learn linear function because they play a very important role in calculus. So what is linear function? Linear function is a polynomial with a degree 1 or less. Okay, so let me give you an example that let me give you two examples. One is geometric, one is algebraic. The linear function always should look like a straight line. Is this a linear function? Yes, this is a linear function because that talks about a positive relationship between two things. Is this a linear function? Yep, this is also a linear function. It talks about a relationship, negative relationship. What should be an example of this relationship? This relationship, for example, can be example of is cops on the street and crime rate. If you increase the cops on the street, the crime rates go down. So the relationship between cops on the street and crime rate is a negative, but there is a very strong relationship as shown by this graph. In this case, there is a positive relationship between x and y. In this case, x could be the number of hours you study and y could be your grade. That means the more you study, your grade go up. So that can be an example. This is two examples of a linear function. This example shows us that the positive relationship between two things. One can be the hours you study a day, and this is your grade. If you study 0 hours, your grade will not be great. So this is a strong relationship. This is also a strong relationship, but a negative relationship. Number of police officers on the street. If you increase the number of police officers on the street, the crime will decrease. I'm going to show you another example. Just to so let's put some number 1, 2, 3. Change of x is in this case 1. What is the change of x? Change of x is still 1. What is the change of x? Still 1. What is the change of x? Still 1. So change of x remain 1 from beginning to end. So change of y should also be same. What makes it linear function? When x changes, y also changes. The change of x remains same, and the change of y also remains same. Let's take a look. What is the case? Change of y from 11 to 14 is 3. From 14 to 19, is it 3? No. Up. It's not 3. 19 to 26, is it 3? No, it's not 3. What it is, you don't care. As long as it's not 3, it's not a linear function. Is it 3? 26 to 35? No, it's not 3. So this thing, this table, the jet on the table does not represent a linear function because it will not be a line. It will not be a negative line. I don't know what it is, but this is not a linear line, linear equation. So now, let's take a look over there. So delta x, we sometimes use the delta x. Change of x. What is the change of x? When x is getting bigger, from -7 to -3, the change is 4. And it's still 2 to 1, it's -1. So when x changes by 4, y changes by -1 from beginning to end. Does that make a linear function? Yes. So this is a linear function. So now you have two examples. One example shows a linear function, a not linear function. The other example shows a linear function. Let's take a look at intercept form. The slope intercept form is y equal mx plus b. Let's understand all the properties in the slope intercept form. I have y, I have m, I have x, and I have b. Okay, so what is y? Y is a dependent variable. So dependent variable. Y is sometimes also called output. Let's put output. Y is sometimes called range. Y is sometimes written as f of x. So these are all the names for the y. What about m? M is the slope. So m can be written as delta x, delta y over delta x. M also can be written as y2 minus y1 over x2 minus x1. M also can be written as rise over run. M also can be written as the ratio. What about x? The x is totally opposite of this one. If this is dependent variable, it's dependent on what? It's dependent on y, dependent on x. So this is dependent. If y is output, x is input. If y is range, then x is domain. B is the y-intercept. This guy is the y-intercept. Y-intercept. It can be written as 0, comma, y-intercept. Okay, let's give you an example to understand it. given 2, 1 given. This is pretty simple. We're just gonna use the slope intercept form. So slope intercept form is y equal to mx plus b. So what is our y? Pretty simple. Our y is 2. What is our m? -2/3. What is our x? 9. What is our b? We're gonna find b, and then we're gonna plug that in over here, and then we're gonna complete that. So 3 goes to 9 3 times. So 2 is equal to -6 plus b. So b is 8. So now we're gonna write the slope intercept form again. Y is mx plus b. So y is m is given -2/3, and x is also given, but we're gonna write x plus. We have now b. What is the b? 8. So now we're gonna graph it. Graphing this one is very easy. We're gonna go to the 8, which is y-intercept. It is somewhere here, because this is arbitrary. This is 5. This is 10. So 8 is in the middle of 10. In the middle of 5 and 10. Okay. Now we're gonna fall 2 units. 1, 2 unit, and we're gonna run 3 unit. 1, 2, 3. So as soon as we have 2 points, we are ready to draw the graph. The graph. This is the graph of y equal to -2/3x plus 8. Now we are going to talk about m x minus x1 plus y1. Okay, the property is the same. Y is independent variable, y is range, y is output, and y is f of x, and is slope. X is independent variable, and everything remains same. This is point 1, this is point 2, so everything remains same. So let's solve this problem example. Okay, so we're just gonna do step 1, and is y2 minus y1, x2 minus x1. So y2 is 5, y1 is 1, x2 is 9, and x1 is 2. So 4/7. Step 2, we're going to use the point slope form. This is y equal to m x minus x1 plus y1. So y is m is 4/7 x minus x1. This is x1, and this is y1. 2 plus 1. So y is 4/7 x minus 8/7 plus 1. So y is 4/7 x minus 1/7. How the graph would look like? This is our y-intercept. 1/7 is a very small negative number. So let's say the y-intercept is right here. Rise 4 units. 1, 2, 3, 4, and run 7 units. 1, 2, 3, 4, 5, 6, 7. This is our graph. This is our graph of this linear function. Now we're going to do something. Higher degree. The linear function is the degree 1. Now we're going to do something that has to do with degree 2, and there is a name when the function with degree 2, and that is quadratic equation. Let's explore this idea in detail. Standard form of a quadratic function is standard form. I'm going to write many different forms. The quadratic function is the most beautiful function, as I just explained, because it describes the behavior of a parabola. So this is like the most beautiful thing. Remember the linear one. The linear one was just ax plus b with degree 1. Now I have a degree 2. Okay, this is just a standard form. What about the factor form? You're going to use factor form many times today. F of x is equal to a x minus x1 x minus x2. What complex form? And what about the x coordinate of vertex form? X minus b over 2a. And quadratic formula is you're going to use many times today. Is minus b plus minus d squared minus 4ac over 2a. And finally, the discriminant. Okay, the discriminant is this one, b squared minus 4ac. Okay, what is discriminant? Discriminant tells us that if I give you a function, any given function, whether the function has any real root. If it does have real root, how many real root? If it doesn't have the real root, maybe it has imaginary root. As you may recall that the number, there are two types of number. There are two types of number, real number and complex number. And complex number. There are 5 types of real number, 5. They are natural number. Example of natural number is 1, 2, 3, all the way to infinity. Whole number. The example of whole number is equal to 0, 0, 1, 2, 3, infinity. Integer. Integer denoted by z. We always going to denote integer by z. So integer is of course 0, plus minus 1, plus minus 2. Infinity, the difference between integer and whole number. Integer includes the negative number. Rational number. Rational number are numbers that has the identical ending. There's the repeating ending. So 1/3 is 0.3333 forever. We go to the right forever. We put it. Don't it? Number 5 is rational number. And irrational number. Number 5 is irrational number is square root of 2, for example. I have a story of square root of 2. I told my student over the summer when I taught bunch of student over the summer at Princeton campus that one of the Greek mathematicians came out with the irrational number. This is 1, this is 1, this is 2. Example of irrational number, it doesn't have the same ending, repeating ending. So we realized that the hypotenuse is square root of 2. And then Greek didn't believe it. Greek thought that this is bad. Greek thought that this type of number, irrational number, made God very angry. and they killed the guy. They killed the guy to make the God happy. They thought that just by killing him, the God will be happy. Now, today we know that the irrational number is as good as any other number. So next time you see an irrational number, treat it same way you treat a rational number or integer or whole number or natural number. What makes it not real number? Okay? Square root of negative something. Say square root of negative 100. Square root of negative 100 is not a real number. It has a part of real number, but it has also imaginary part. So let's see. Let's separate the real part from the imaginary part. So negative 1 and 100. Negative 1 is square root of negative 1 gives us I, and square root of 100 is 10. So 10i. So this is the real part, and this is the imaginary part. Now we use the discriminant to understand that whether a given function has any real root. If it does have the real root, then how many real root? Let's give you an example. This is graph number 1. This is graph number 2. This is graph number 3. And this is graph number 4. One thing we need to know that when the coefficient, this is a coefficient, this is a leading coefficient, when the coefficient is positive and discriminant is positive, then there are two roots, two real roots. How many roots? 1 and 2. Two real roots. Do we know the value? No, we don't know the value. We just know this, when the leading coefficient is positive and the discriminant, what is discriminant? This is just equation. I'm going to explain it by giving you an example real soon. Discriminant is positive, then two real roots. Okay, what about this one? When the discriminant is 0 and the A, which is the leading coefficient, is positive, then it has one real root. Yes, there's one real root. When the discriminant is less than 0 or negative and A is, doesn't matter, it doesn't matter, then it has no real root. It has no real root. It has an imaginary root. Only imaginary, no real root. No real root. And I explained a few seconds ago that the square root of negative 100 has two parts. One is imaginary part and one is the real part. The real part is 10 and imaginary part is I. So the square root of negative 100 is 10i. However, this guy has no real root. What about this guy? D is of course greater than 0. What about A? A is less than 0. A is negative, so it has two real roots. We see that. So the discriminant, as long as it doesn't matter, if A is negative, then it still will have two real roots. But the parabola would be the upside down if A is a negative. If A is positive, two real roots. Parabola is a regular parabola, an upward parabola. So let's explore some examples. Okay. Alright. So let's find the discriminant. As you remember, the discriminant formula is can come from quadratic equation. Quadratic equation is negative b plus minus b square minus 4ac over 2a. So the discriminant is this guy, b square minus 4ac. Now let's list what is a. A is 2. What is b is negative 3 and c is 1. Okay, let's plug that in. B is a negative 3 square minus 4 and A is 2, which is the leading coefficient, and C is 1. So D is a 9 minus 8. D is 1. We don't care whether D is 1 or 1 million, as long as it is positive. So D is positive. That means this function has 2 real roots. Okay. And the function is upward because the leading coefficient is 0, as you see right here. So let's find, we know that there are 2 real roots of this function. We still don't know the value of it, whether it is 1, 2, 3, 4. We don't know. So let's find that out. Write that formula again, minus b plus minus square root of b square minus 4ac over 2a. So b is negative 3 plus, you're going to write just d because that's b square minus 4ac is discriminant. 2a is the leading coefficient 2. So this is 3 plus d, we already found d. D is 1. The square root of 1 over 4. So 3 plus the square root of 1 is 1 over 4. And by the way, this is plus minus, this is plus minus, this never made that mistake, plus minus. So it has 2 real roots. We discovered that before. Now we know the value of 2 real roots, and they are 3 plus 1 is 4 over 4, and 3 minus 1 is 2 over 4, which is 1 comma half. Now we're going to go back to the factoring form of quadratic equation. Factoring form of quadratic equation is f of x is a is 2, x minus x1 is 1, and x minus x2 is f. This is the factor form of this quadratic equation. Any quadratic equation can be solved this way. First, you use the discriminant to find that how many real roots. Then you put that in quadratic formula to find the value, and then you use the factoring form of quadratic equation, which is f of x is a, x minus x1, and then x minus x2, and then you write it in a factor form. So any quadratic equation you can do using this way. Bx plus c we can write x squared plus bx plus b over 2 squared minus b over 2 squared plus c. So this guy is x plus b over 2 squared minus b over 2 squared plus c. We can say that because a plus b squared gives us a squared plus 2ab plus b squared. That's binomial formula. Okay, so now we are doing max. Find max of this equation. How can we find the max of this equation? What is even max of the equation? Earlier I told you, if I throw something, the max is at the point when it changes the direction, or at the point when velocity is 0, or at the point when the truck is stopped. Did you see that truck is stopped? No. but we knew that chalk had to stop in order to change the direction. The math allow us to things we don't see, but math allow us to understand that. So let's do that. F of x is x squared minus 4x minus 1. So f of x is minus x squared minus 4x. Remember, this guy is bx. So bx, what do we do? We divide by 2 and square it. Now we're going to divide 4 by negative 4 by 2 and we're going to square it. If we do that, negative 2 and negative 2, someone in the class thought that it would be negative 4. It would not be negative 4, it would be only 4 because negative 2 times negative 2 is 4. So we have a plus 4. If we have to put plus 4, we have to write minus 4. Then plus minus cancel. That's the whole point. Putting the negative 4 meaning that as if you didn't do anything because they cancel each other. F of x is equal to minus x minus 2 squared minus 4 minus 1 is minus 5. You multiply with this minus, that would be plus 5. If you don't understand this part, you can see me after the class. This is basically we're using a minus b squared. In this case, a is x and b is negative 2. And a minus b squared is a squared minus 2ab plus b squared. I just don't want to take all the class time to explain things that you should know. If still you have a difficulty to understand that how did I write that, see me after the class. Okay, now we have this in this form. We can draw a graph. Is this upward parabola or downward parabola? This must be downward parabola because the leading coefficient is negative. Because what is the leading coefficient? Is negative 1. So it's negative, so it must be downward. So there is downward. And there is negative 2. So this is positive 2 and this is negative 2. So where should I go? Shift it to left or shift it to right? Shift it to right. Keep that in mind when you see negative, shift it to right. And there is a 5 sitting over there. So this is 5. So 2, 5 must be here. So the parabola, this is the parabola. The parabola stops here. The parabola stops here and come back. So at that point, this is max. And the max is 2, 5. This is finding the max using the completing square without using the derivative, without using the first derivative and second derivative, without using the concavity, all those fancy stuff, but we eventually have to do that some few weeks from today. So we'll end here today. I'm going to give you a break, and when you come back, we'll do trick.